In our world today, where people often find themselves navigating multiple healthcare providers, consulting various physicians, or overseeing health records of an entire household, this challenge has become increasingly prevalent. In my own experience, I have a primary care physician here at MIT and another one back home. When I attempted to compare lab results and diagnoses between both doctors, I found myself logging into separate portals and sifting through the reports to locate the necessary information. And this was definitely a time-consuming process. And this is precisely where our innovative solution comes into play, Fusion. Fusion is a cutting-edge platform designed to seamlessly unify medical data, empowering individuals with the information they need to make informed decisions about their health. Let's take patient Jane Smith as an example and see what Fusion does for her. Jane is shopping around for different doctors to find the best treatment for the price. She's evaluating 3 different health conditions and visits these doctors. Take a moment to consider the extensive amount of medical information individuals like Jane need to manage for themselves. This is a huge hassle. Now, furthermore, let's also observe Jane's family. She has 6 individuals other than herself to take care of: her mother, her father, her husband, and her 3 children. How can she manage all of their medical data effectively? Our solution, Fusion, offers enhanced comprehensibility. We streamline all medical data related to a specific condition on a single page and simplify the record management. The most critical information is very prominently highlighted. There is also insightful health management, i.e. interpretability. Navigating your health journey with ease as you compile your medical history, past visits, and progress over time into one comprehensive view. And eventually, we can also unlock tailored recommendations for the well-being of both you and your family through Fusion. So we often also have user-friendly graphics on our website to show all of this information, as well as condensed data and condensed text to show you what your medical information is that you want to get away from your visits. So now we'll talk about Fusion's flow. So you input PDFs or text versions of your doctor report. And what we do is we parse and identify keywords in the PDFs, and such as, what is your complaint? What is your objective problem? Why did you go to the doctor? And then we also look at the history of your medical history in general, and take a look at that, and what allergies have you had, any prior conditions, etc. And then we also look at things like assessment and plan. What does the doctor think is going on, and what is the treatment plan for this? After that, we hope to use an NLP model to identify similarities and differences between the doctor notes and recommendations, and hope for predictive modeling, such that we can find what your conditions are truly and provide you with a summary of what your conditions are from different doctors. And last but not least, we have our output, the way we present our information. It's a user-friendly front-end user interface created by React.js and Purity UI, organized by doctor and or condition, depending on which way you want to look at it. And in addition to this, it also will have multiple profiles for maintaining your family's medical details, and you can easily look at all the summaries. So that's about Fusion. Now we'll continue to look at the front end of this project, and we will see how Fusion looks in play.
So in terms of the implementation of Fusion, this will be our website. And in terms of our website, we have several key features that we need to implement. For one, we have the 3 doctors on the top for Jane Smith. And this UI interface is mainly done so that Jane Smith can easily check who, like, the 3 doctors she currently has. Below that, we have like the commonalities between all 3 doctors and what they said in terms of their prescription and analysis, and also differences. And in terms of more key metrics, the bar chart will give Jane Smith data on how much time she spent in treatment this month or per month, and below that shows how much time Jane Smith has spent, like the average time per week that she has spent in treatment per week per doctor. In terms of the last chart, this will showcase the cost of coverage per doctor. This is a monthly average, and this will showcase data for Jane Smith if she wants to compare between the cost of each provider that she has. Another key feature we will have, this is for future reference, is a payment system. This is mainly for like a feature for Fusion, in which we will have like a monthly subscription service. So this will be a way for a user to implement their payment information.
So at a lower level of abstraction, how do we actually work with all of these doctors' reports as input? We're using natural language processing, or NLP, which allows computers to be able to read text, hear speech, and perhaps most importantly, be able to interpret it. There's two parts to this NLP, and the first one is summarizing the doctor reports that are relevant to each of Jane's individual visits. So, for example, we have a paragraph of what type of plan a doctor recommends. And from that, we look at the keywords and phrases, which are, in this case, medication X, Y, and then a blood test you should get. And then we form a condensed version that we can display on the website. And the second part of the NLP is comparing reports between different doctors in order to glean cool insights that we wouldn't have been able to do otherwise. So for example, we take in our input, which are the original text files for each of the doctors, and then we identify the overlaps between them. So what's common, and then we look at the similarities and differences and interpret that. So we're using Python on the back end and hopefully looking to use SQL for database purposes in the future. The thing that makes this NLP problem unique is that we're dealing with medical data and very niche terminology. So it's not likely that some classically trained NLP model would work well for our purposes. Thus, we're currently working on implementing a text summary technique that's put forth and endorsed by the Unified Medical Language System, or UMLS. And that's an information database from the National Library of Medicine. The UMLS is a set of documents and files that brings together many health and biomedical vocabularies and standards for normalization. In order to train and evaluate our models, we can query Wikipedia to get lots and lots of biomedical data, and that's going to be super helpful. And then let's walk through how we're working on doing our text analysis and text summarization. So there's a similarity algorithm used to cluster related sentences in the original text. And from that, we can discover the frequent items or keywords and phrases that are being used between the sentences through some second algorithm. We can also specify. And then to construct the summary, the crucial sentences from each cluster are chosen to figure out what are the things that are frequently appearing in different types of texts. Putting these steps together yields good clinical text mining, and this would provide a pretty good summary of what's happening and condense that for the user. A similar process would be used when we're comparing two separate pieces of text against each other. We'd still be looking out for keywords and figuring out what's common between the texts. The additional step is when we're looking at the differences between what Dr. A said and what Dr. B said in this example for Jane. The particularly challenging aspect comes when we have to figure out how particular text differences are actually fit into some contextual scheme. So are they really meaningfully important? Are the doctors really saying different things? And that's something that we're currently working on. And from here, we're able to parse further, make user-friendly graphics, and show analyses, as we saw in the UI earlier. A goal is to also use what we have to perform predictive analyses and hopefully provide novel insights for the user. So for example, we could look at Jane's current treatment plan, what she's following, and maybe show projected costs and show which of these would fit Jane's interests best. Additionally, we'd be able to maybe even use Jane's symptoms to perform some sort of predictive modeling. But that's for the future and something we're looking out for.